Now with ordered pairs or a table, we can either use the slope formula to find the slope and then identify it as either positive or negative like an equation, or we can simply identify how the x-coordinate and the y-coordinate are moving. Remember, two positives or two negatives make a positive rate of change, and one positive and one negative make a negative rate of change. So here we have an example of a table, and we can see that the change in the x-coordinates is plus 1, plus 1, plus 1, plus 1, plus 1. The change in the y-coordinates are plus 3, plus 3, plus 3, plus 3, plus 3. So in the above case, we can see that both the x and y coordinates are moving in a positive direction. So that's like a positive over a positive. So that creates a positive slope and a positive rate of change. Now take a look at this table. In this table, we can see that the change in the x-coordinates are minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. And the change in the y-coordinates are minus 3, minus 3, minus 3, minus 3. In this case, both the x and y coordinates are moving in a negative direction. So it is also a positive rate of change. Think the slope would be a negative over a negative, which is also a positive. A good way to think about it is if the movements match, if you have two positives or two negatives, you're going to have a positive rate of change. Now also note, if we use the slope formula, or the slope for the rate of change, it would be positive in either case, right? It would confirm in the first table, if we use the points 1, 3, and 2, 6, in the slope formula, we get a positive 3. If we use the points of 5, 10, and 7, 4, we also get a positive 3. In this case, both the x and y coordinates are moving in a negative direction, so it is also a positive rate of change for that second table. So you have those positive rate of change because it's confirmed with the slope formula, or it's just the movement is the same. Now let's look at this example though. We have the following ordered pairs. We have 1, 4, 2, 2, 3, 0, 4, negative 2, and 5, negative 4. So notice that while the x values go up, we have 1, 2, 3, 4, 5, the y values go down. 4, 2, 0, negative 2, negative 4. So this is an indication that there is a negative rate of change because one value is going up while the other value is going down. Now it's not matching. But we can also use the slope formula to figure out if it is a negative rate of change as well, right? If we use the first and second points in the slope formula, we can actually calculate and see that the slope is a negative 2, so that would just confirm you have a negative rate of change. So whether you're looking at the movements or using the slope formula, you can still find the slope of these functions and then identify it. If it's a positive slope, it would be a positive rate of change. If it's a negative slope, it would be a negative rate of change.